Hi everyone. Many of you had requested me to explain the concept of Coriolis force related with the climate chapter. Now let's take up this concept. Now first question is, what is Coriolis force? Right? It refers to the tendency of object to maintain their motion when they move from one place to another. Let's see how it works in case of Earth. Now you know that Earth rotates on its axis from west to east. This concept you know it very well since your very junior classes. Now, Earth rotates faster at the equator than at the poles. I repeat again, Earth rotates faster at the equator than the poles. That means this is equator and these are poles, North Pole and South Pole. You know it very well, right? This is because Earth is wider at the equator in comparison to poles. You can see because Earth is a geoid spherical, Earth is wider at the equator and it is squeezed at the poles, right? That is why Earth rotates faster at the equator than the poles. A point at the equator travels faster than a point at the pole. Coriolis force in the northern hemisphere. Understood the concept? That means Earth rotates from west to east, right? And it always rotates faster at the equator than the poles. Why is it so? Because it is wider at the equator in comparison to poles, right? Then it says a point at the equator travels faster than the point at the poles. That means whatever object we will have at the equator will travel faster as compared to the pole. Now let's take up the Coriolis force in northern hemisphere. Let's pretend, I'm going to explain you this with the help of an example. Let's pretend you are standing at equator, want to throw a ball towards your friend in North America. That means you are standing at the equator, and you want to throw a ball towards your friend in North America. We are talking about the northern hemisphere. If you throw a ball in a straight line, then it will appear to land in the right of your friend. I'm repeating again. Let's pretend you are standing at the equator. That means you are standing at the equator over here and you want to throw a ball towards your friend in North America. So North America lies in northern hemisphere. We are talking about northern hemisphere. If you throw a ball in a right line, it will appear to land in the right hand of your friend, right? If you throw a ball in a straight line to your friend, it will appear to land in the right hand of your friend because your friend is rotating along with the earth at slow speed, because Earth is rotating at a slow speed because we are moving towards you are standing at the equator and you had thrown the ball towards the North America, right? But the ball will maintain a speed of rotation at the shift of the equator to your friend. But definitely ball will travel, ball will rotate at this speed at the shift of the equator towards your friend. Therefore, ball will appear to have moved to the right side. So that is why ball appear that it has moved towards the right hand direction towards the equator, right towards the pole, right towards the northern hemisphere, and left hand side in the southern hemisphere. Same way in the southern hemisphere, it will appear to have moved to the left side. Thus, we can conclude on account of the Coriolis force, winds and ocean currents move towards the right hand direction in the northern hemisphere and left hand direction in the southern hemisphere. That means whatever, since any object, any fluid which is present on the earth, maybe the winds and the ocean currents, which will work or move towards the equator, towards the poles, they always fall at the right hand direction. And if they move from the equator in the southern hemisphere, from the equator towards the southern pole, they always move towards the left hand direction. I hope I made this concept clear. Thank you.